Thank you for coming to our cozy session about migrations. If you came here at 5:20 on the second day of a very busy conference, I get that you are quite interested in the topic. So today we'll talk about approaches to migrations, why migrations are hard, and I will talk about specifically a customer that we, as a technology partner to Databricks, help migrate from a combination of legacy technologies that are particularly gnarly to migrate, SAP HANA as well as Talend. So my name is Gleb. I am CEO and co-founder of Datafold. We are a technology partner that focuses on automating migrations to Databricks as well as the broader modern data stack ecosystem. Before starting Datafold, I was a data engineer and I got a chance to build 3 data platforms at companies including Autodesk and Lyft. At Lyft specifically, I led a massive migration of a petabyte scale data warehouse that was unfortunately a massive failure, including for my career, for a number of reasons. One of them was a bad approach to migration because we chose not to do lift and shift and instead to remodel the data as we go, which was the most terrible decision one can ever make for a migration. And the second big problem that we had was the complete lack of tooling and automation to actually run a migration of that scale. And that is exactly what we are here to fix with Datafold. A few words about Evri. So Evri is a large enterprise in UK that is essentially a delivery service. They use data for a variety of use cases, including real-time analytics of their warehousing operations, and they have, I would say, a fairly large and complex data model for a typical enterprise. So when we started working with Evri, the state of things was that they bought Databricks, which is really a great decision one can make. Unfortunately, they have not been taking advantage of Databricks pretty much at all because most of their business logic was stuck in legacy systems, including SAP HANA and Talend. And even though they could stream the data into Databricks, they couldn't really do a lot with their data because all the business logic and all the workloads were stuck in those legacy systems. On top of that, the problem was that, as you know, systems like SAP HANA and Talend are extremely expensive. And the big goal for Evri this year is to be able to cancel the legacy contracts so they can successfully move to Databricks and do the fast and successful cutover. The scale of the legacy environment, I would say, is medium-high complexity. There are 4 NDSO pipelines that are essentially incremental dimension pipelines in SAP HANA, over 2,000 views and other objects in HANA, including calculated views. So, a lot of business logic to deal with, and over 200 talent jobs. And when we started working with Evri, they were in a situation when they were very clear that without automation, there is no way that they would be able to complete this migration this year, given the current scale and the pace of the migration. So now that we set up we understand the layout for Evri, let's talk about migrations in general. So migrations are really the least fun of projects that we can run as a data team because they're extremely expensive and extremely tedious. And the expensive part of migration comes obviously from the amount of engineer hours it takes to migrate, but there's also tremendous indirect costs because just like Evri, until you're fully migrated, you're essentially double paying for infrastructure, both for the modern stack and the legacy stack. You're likely missing SLAs because your old system is under a lot of load and you probably can't do much on it. You're losing a lot of productivity because you can't build all the things and it's really slow to build in legacy systems. And there's also tremendous opportunity costs because if you are stuck in the migration, you're probably losing a lot of your attention and hours and engineer hours on that project instead of shipping really exciting things like data products and AI. So there's a really strong incentive to get migration done as fast as possible. One of the most counterintuitive things that I always discuss with people in the migration or in general is that when you say, oh, we're migrating someone from legacy to the modern system, everyone thinks that it's all about moving data. And as you probably know, if you're in a migration, that's the least of the problems. Data is very easy to move these days, not really a problem. It's all about migrating the code and workloads, because if you're moving from legacy to a system like Databricks, migrating code involves not just changing dialects, but oftentimes completely rewriting all the legacy paradigms, store procedures, and re-architecting the whole pipeline. And that is an extremely, extremely tedious process that historically was done by consultants, professional services, and SIs, which led to long timelines and high costs. So obviously, there's been a strong need for accelerating migrations. And for probably about 2 or 3 decades, the primary technology that's been used for accelerating migrations has been static compilers or transpilers. So systems like BladeBridge and open source tools like SQLglot that essentially take your legacy code, decompose it into abstract syntax tree, and then recompile in the new system. And those were helpful, but the challenge is that at most, they can help you convert between dialects, but they are not capable of doing any kind of significant refactoring or repackaging into a new orchestrator or changing paradigms. And that does not simply meet the needs of the current enterprise migrations. So at most, you get some acceleration. The metaphor that I really like to use is using a tool like that, a static compiler, is almost like having a sponge when you're about to wash dishes. It's more helpful than just washing dishes with bare hands, but ultimately you still have to go object by object, use the tool, translate the code, and then do all other parts of the workflow, including QA and bug fixing and refactoring and repackaging. Ultimately, it's still a very manual and tedious process. And the way to scale that historically been hiring more people, usually consultants or professional services, that would operate these type of transpilers so that the process runs faster. But it's still extremely manual. So now, obviously, it's 2025, and this conference is all about AI. So one thinks, well, let's just have LLMs do all the work. And obviously, that's the promise, but not so fast. There are multiple challenges in using LLMs. LLMs are really great and really awesome in solving the key limitations of the legacy technology. One is they offer unparalleled flexibility. Unlike static transpilers that are extremely complex to develop and they rely on grammars, LLMs can understand any code, right? They can write any code, they can read any code, and that's really easy to get going on any kind of code translation. They have reasoning capabilities, so they can actually think like what kind of pattern is better. And they provide a more effective layer of abstraction, right? If you're dealing with a static transpiler, you can't improve anything unless you actually improve the grammar, which is extremely complex, and the parser. Versus with LLM, you can just chat with an agent and say like, hey, I actually want this store procedure to be migrated into Databricks live DLT pipeline. However, there are really big challenges with using just plain LLMs. And one of the challenges is that LLM is a technology, it's not a solution. Just like having a virtualized instance on AWS doesn't necessarily mean that you now have a working microservice. Just plugging in the code into LLM doesn't solve the migration challenge for you. One of the problems is hallucinations. So LLMs are really good at generating code, but no one guarantees that they generate correct code. And having incorrect code as a result of migration has absolutely zero value. And LLMs also have limited context window. You can't just like stuff in a million line of code base from legacy and translate everything. So it's helpful, but it's not the solution that we need. One of the biggest problems for migrations is validation. None of the business stakeholders or business users would ever say, we're done, yes, cool, we're gonna use Databricks, unless you prove that every single legacy asset, like a data set or a view or a BI report that was built in a legacy system is completely reproduced in the new system, and you show them a proof that both things are identical, right? Because otherwise business just does not trust the data, and they don't really care whether you use Databricks or SAP HANA if their numbers don't match, right? That's a really, really bad position to be in. And when we worked with our customers, we asked them, where are you spending most time during a migration? And the overwhelming number of people said that the most tedious part in a migration is actually the process of validating the outputs on a new system against the old system and reconciling the differences. And that is not something that LLM can actually help you with, because that still becomes a manual part of the process. So we at Datafold are experts in data validation. Even before LLMs were out there, we've been developing very, very extensive testing capabilities, and we are known for a tool called DataDiff. Essentially, DataDiff allows you to compare data sets between any kind of database at scale at value level precision. So you can run trillion record comparisons between Snowflake or Databricks, or SQL Server or Databricks, or even files, or even NoSQL databases against any kind of OLAP system. And that is really the fundamental part in the migration process, because it allows you to do the validation after the migration is done. Now, back to the metaphor about tooling for migration, right? We talked about how having code transpiler helps you with conversion, but without the validation, it doesn't really solve the problem. You're still stuck with the manual process. Well, if we take AI and we couple that with the data diff for validation, we can essentially get to a dishwasher that, instead of having better tools to wash dishes, just produces clean dishes for you. So it is something that enables the outcome. The way this works is we have a very straightforward, conceptually, agent that takes the legacy code, builds a graph of that legacy code so it understands how all the objects interact, how all the dependencies in data work. It then builds a testing environment so it can validate the legacy versus the new world. And then it does the translation and refactoring. So basically going over every stored procedure, or sometimes multiple stored procedures, converting them into whatever should be the code on the new side, whether it's Databricks workflows or Delta Live tables or Databricks and dbt. And then it does a very simple thing. It compares the output of the code in the new system with the old legacy output. And if there are any discrepancies, it then takes those errors and feeds them back into itself for correction and reconciliation. So essentially, what it does is exactly what a data engineer would do during a migration. But the huge advantage here is that it is an automated system, so it can do that at scale, which is where the acceleration is coming from. Another really cool effect of using an AI-driven migration is that it's not just about translating code and making it run. We can also improve the code in the process. So one of the big problems with legacy systems and in the migrations is that the patterns that are used historically in legacy systems, like stored procedures that are linked together and they call each other and they do incremental updates to tables, are really dangerous if you replicate them into a system like Databricks, because you essentially end up with a completely unmaintainable code that is really hard to develop, that is most likely going to be slow and expensive to run on a system like Databricks. So ideally, you are refactoring those patterns into something that is really following the best practices on a modern system. So as an example, what we've done for Evri is a complete refactoring of the SAP HANA and DSO pipelines that took about 6,000 lines of SQL each into a Databricks structured streaming pipeline. What this allowed us to do is, one, make the code way more maintainable. So we ended up with 3 times fewer lines of code, which already is a big achievement because that means fewer moving parts, fewer things that can fail. 2, because of Databricks' structured streaming abilities, you don't have to maintain watermarks and complex checkpoints as you would with stored procedures. Everything is just working out of the box. It's scalable. So in the old world, in SAP HANA and stored procedures, the customer had to run their Sprock pipelines multiple times manually to just backfill the table because SAP HANA wasn't able to handle the entire job in one go. But with structured streaming, there's no such problem because everything is processed continuously. So if we need to process 10 billion events, that can be done automatically with automatic handling of scalability. And finally, the real cool thing, which wasn't really a requirement here, but it just comes out of the box with Databricks, is you can get this pipeline to compute in near real time if you want, which was completely unattainable on the old system. So again, the AI-first migration approach allows us not only to replicate the functionality of the old system, but to improve it and make it run as effective as possible on a modern data platform. So what does it mean for Evri? So this project is still ongoing, but we already delivered multiple phases, and they are on track to move completely from legacy platforms, SAP HANA and Talend, over to Databricks. And another advantage of using AI that Evri's taken advantage of is the ability to package the code exactly how the customer needs it. So for example, some customers we work with, they like dbt for orchestration, but Evri prefers to use Databricks native functionality for all their code. So we can package the code exactly as the customer needs. In this case, it was Databricks asset bundles. And from the customer's perspective, what they give us as the code, what they get is code that's completely packaged, ready to run, and proven to produce identical results. That's really what you want for a migration. That's it. That's the Evri success story. And if you have any questions, I'm happy to chat. And we also have a booth right there, number 313. So come by for cool swag and a deep conversation about migrations. Thanks for coming.